Zoe here, hi. So I guess we promised you some adrenaline in the comments, I think. So let's get right down to it. So you have amino acids, yeah, in your um, body, and like they are stored in proteins. Like proteins are made out of amino acids, and you know what, this is just our preference that like you don't have to copy this, but to make it easier for us we always noted carboxylic acids with Q, so like we did this just so you know that it made things easier for us. But so basically, what are amino groups and what are acid groups? So, like what's organic chemistry? So organic chemistry, yeah, uses carbon atoms. It has like 4 valences, so you can have like up to 4 hydrogens attached to a carbon atom, and because these all have like just one spare electron, this has you know 4 spare electrons, and when you connect all these, then you have an octet. You have an octopus worth of electrons, a spider legs hands worth of electrons. So that's pretty much it. You kind of want these 8 electrons, or 2, like in the case of 2 hydrogens each having an electron, then like these are nice covalent bonds. These are equal. These as well, but like some stuff like natrium and chlorine, like these want to give their electron over and have here just like their previous octet, you know. They want to give this one over, and this chlorine already has 8 electrons, so it actually wants to take this over. So give and take is the name of the game, even for atoms and ions. Like these are ions already, like these are ions, and these are like with covalent bonds. And yeah, I'm getting too deep in this, and this is inorganic or inorganic depending on language, um, you know and this is organic, and we are going to get into this. Like I might as well just get into it now, because otherwise I will go on other tangents. So supposedly, like this is cyanhydric acid, and if you don't know what this is, well, long story short, it's not good for you. Okay, let's leave it at that. Like this is like very safety first, like this is like on the level of substances that you really want to handle with the gentlest of fires, to keep to the whole fire allegory going through my channel. But anyway, so these are 5 hydrogen, 5 carbon, and 5 nitrogen atoms, and they form like like they form their bonds like this because, hey, uh, it wants these 3 electrons from the carbon to have its octet, and the carbon already has its other 4, and with this one from the hydrogen, like that's how they have their octets, and the hydrogen already had one, so it has its doublets. So everyone gets what they want, what they need, to quote Bo Burnham. And so yeah, so why am I writing this? So this is inorganic or inorganic chemistry, right? So why am I writing this and talking about organic chemistry? Supposedly right amount of pressure uh, and temperature. supposedly with luck and time and the right Goldilocks conditions, like where it's not too hot and too much pressure, but also not too little, eventually they can form and supposedly formed adenine, and this is one of the base nucleotides of DNA and RNA. So DNA being the double spiral, the double helix. And okay, I need to learn to work with the camera and so on of my phone and actual stative and such. But yeah, so this is adenine, and this will be important because like normally it has this hydrogen atom here, but when it doesn't, when it it can go and bind with saccharides, and those are tricky. Those will be tricky, and I did not like them, but I had to study all summer to pass. So let's just say that you will be hopefully in good hands still with me. And like this is now adenosine, like this whole thing now, like this would be just adenine. And then you have you can replace this with a phosphor atom, and then that one will also need some of its electrons, and that's how we will get adenosine monophosphate, AMP. And if you want to go even further, then you can add another one, and then it will be adenosine diphosphate. And then if you want to go even further, then you can get adenosine triphosphate, ATP. You will have heard about this. The mitochondria is the powerhouse of the cell and all that. The thing is, like, it really does need the actual energy from from these bonds between ATP and ATP, and like these are going to like pass energy over, like this is how energy transfer happens, and like these nucleotide bases with their saccharide sugars in RNA, one of these hydroxyl groups is missing, and you see, even I don't remember which one is missing. I will have to look that up, and thankfully that's something that I can look up. Something like adrenaline intracardiac dosage, that's not something EMTs can have time to look up. So if I mean, don't try anything from fiction, but anyway, yeah, so basically where I was trying to get to, like, from inorganic chemistry, supposedly you can get to the first nucleotide, which in turn can convert into other nucleotides, like it's a nucleotide. And yeah, so that's basically that. And so yeah, where was I going with this? So ATP, like you need these double helix DNAs, and you need RNA without this sugar and so on to have messenger transfers for DNA to even work and to be coded and so on and so forth. And it's a fantastic field, and I'm delighted to talk a lot more about this. But also, like, what's this? Like, you might have seen something like this in your life, but not with nitrogen atoms inside. Like, what's this all about? And what's with this fusion with another ring? And what's this double bond here? Okay, nitrogen needs like some electrons too, even if not as much as carbon. And actually, like, what's this? So, like, let's draw in the carbon atoms. Like, let's just draw them in, and let's do some counting. So I said we had 5 hydrogen, we have 2 here, we had this one, this was the third one, this carbon atom had 3, so this one has 4 now. This nitrogen has nothing. This one has 4 and 4, but this one has 3, so this is the 5th hydrogen. Okay, hydrogens we can cross out. Okay, and so carbon atoms we said 1, 2, 3, 4, 5, and nitrogen 1, 2, 3, 4, 5. All right, so this is why they speculate that this is like, I don't remember exactly, and I could look that up, but you know what? I leave that as homework for you to reliably fact check. How do you reliably fact check something like this news of them finding something like this adenine, not adenosine, mind you, but adenine on some other part in space. But anyway, so I asked about these, nucleotides, and let's go back to the basics, because so like we have, the snake that, chases its tail, the cat that chases its tail, like this is a recurring pattern in my videos, and there's a metaphor and everything in there. And anyway, so yeah, and yeah, so this is basically like, you could even just like write it like this, or I would prefer it honestly to just even write it like a spiral, but like, I mean, that, like not everyone will agree with me starting something like this, but that's just my own thing. Anyway, so you could just like write it like this, and also like I'm looking into my phone camera, and that's why I'm drawing oddly, because there's some delay between phone camera and such. Otherwise, yeah, I really need to figure it out. So you could write like this. When you fuse two rings, then it's has preferred to just like yeah, I just prefer to write my yeah, I like my phenothiazines like this. Like these are my brave mutalisks. These sulfur and nitrogen phenothiazine mutalisks, and yeah, that's not actually how that cannot work. So you have to have this hydrogen there, because this carbon atom already had 4. Anyway, so basically let's take pyridine, because you saw these are with carbon and hydrogen. Let's take a simple nitrogen ring, and you basically have, I don't know what are the limits, but you pretty much have or can synthesize. Some are not worth it for various reasons, but so nitrogen ring, this is pyridine, and it's py for short. It's not, don't confuse it with pi. That's why with y. But yeah, it's useful to know these shortcuts, because if you work in certain uh, yeah, context, then it just is a lot easier to not to have to look up all these meanings all the time. So if you had some radical here, that would be the picolines. If you have a radical here, that's the nicotines. Why is that the case? Well, the case for that is that we always name something after their acid, and this is nicotinic acid. That's why like you can have nicotinamide, which is like B3, and both forms are actually B3, but this one is more stable, and yeah, like the amide form, like this is an amide when, like, I mean, the COO group plus like let's say ammonia, like that will become CO, and like this is a radical, or is radical always. You can also like write it like that if you don't like that kind of notation. Anyway, so that will become CONH2. That's That's correct. Okay, so that's an amide. That's why it has nicotine amide in its name. Okay, so where do I want to get to? Well, we have isonicotines, and I snuck one of my accounts into a video where I posted using one of these isonicotines as names, and again treasure hunts, and yeah, like these are isonicotines, and you have the isonicotinyl hydrazide. So this will be I will just write it like this. Hydrazide is when you don't just have an amide, but you have like an amine, if that makes sense, like hydrazide or like I wrote this oddly, so I will just write get rid of this. So this is isoniazid, and it's an important TB med, but there's polyresistance and everything going on, and there are a lot of considerations, and you can get it out of citric acid, which I like that method, but I will not talk about it now. And this is pretending to be a metabolite. I could say fake metabolite or false metabolite, but I'm thinking about how to teach AI not to use false or fake or whatever, but pretending is also not a good word, even though The Pretender is a good Foo Fighters song. So basically, supposedly the way it works, and the thing is, every source I checked had something slightly different about this, so I actually have no idea how to fact check this. And like, I do want to go deeper into this, and maybe I will finally now do it, but I will just say that supposedly the way this works is that this sort of interacts with the actual B3 vitamin in TB bacteria, but also in healthy humans. And like the way nicotinamide works is by forming the nucleotides with adenine. Like you take this, and from here on you again wrap a mirror image of this together with this, and then supposedly, according to some sources and logic, this could replace this. And even more bizarrely, supposedly it interacts with another thing, and that one is also it's also an isonicotine partially, but also not. And I forgot how its radicals were, if it had a hydroxyl here or what. But I will just show you. Something. What is it? Like, it's also picoline, and it's also nicotine and isonicotine, but this is the main part, and it's an aldehyde, and aldehyde means that like you have the double bond O, like the carbonyl group there, and the hydrogen there. Plus you add in, let me properly do this, if you add in CO and H, and it's so hard when I'm looking through the camera rather than through my actual other stuff. This is the lesson 0 for me, okay? I will redo this. Then this becomes hydrazone, and I can just even write the radicals on the other side, which is probably how they will move anyway to make room for their new hydrazone Zerg overlords. So it's like C age, and then you no longer have that. Like let's just take this and say, okay, like this goes away, and you know what, like how does this work? Okay, did this work now? Did this actually work? Because the thing is, so you see, long story short, I have no idea what I'm talking about, and this will just be as a lesson 0, just so you see what happens. So the main thing though that I wanted to show you regarding this part and whatever is, yeah, pyridine, piperidine, and there's the radical this is piperine. So they extracted this from piper different species. No, not the on the fully hydrogenated version, and this is the version without the radical, you know, like remove this radical and add the hydrogen. This is piperidine, and so I said that, you know, this is pyridine, and like it's missing that p, and I tried to fact check this, and I found no sources that said that piperidine and pyridine would have any connection whatsoever. I will go further and say that piperazine, which is like this, you can imagine carbon atoms, like 4 of them here, and with each 2 hydrogens on them. This is piperazine, and then there's pyrazine, and last I read, I'm not sure about this anymore, but I think even in this case they said there's no you know, connection. Are you kidding me? Like as far as rumors go, I'm just going to start the rumor that the hydrogenated forms are with p, you know, and the ones like that are without. And this was a long roundabout way to teach you about how these exist, and like these will have you know like okay, so like this is already, like this is nicotines, then it would be pyridines only like this, yeah, like nicotines would be the whole thing, because nicotine itself is, let me just write it here, like, the elephant in the room, what does this have to do with nicotine? And nicotine is, I said nicotines start from here, and yeah, and if you don't write it in, it's assumed to be a CH3. I'm just going to write it in just for the, yeah, you know, so you see it. And this is a pyrrolidine ring, and if it had 2 such things, then it would be a pyrrole ring. And you see you will have quite a lot of rings to deal with, but don't worry, because most of them are not going to be that important to us. Some will be, and some of them we will talk about here. And we want to talk about adrenaline, and so we talked about amino acids. So I said, okay, an amino acid like necessarily has a carboxylic group, which again, like that COOH is like RCOH, like the radical comes here somewhere in space. It's, you know, also in not universal space, but also you have the carbonyl group, like this an aldehyde or ketone, but with the OH, this is a carboxyl group now. So you always have an amino acid. We're talking about organic acids here. Organic acids will have this, and not all, actually, like we will talk about sulfonic acids and other stuff very soon, actually. So like CH, and then you have NH2, because we want the amino acid, and most of them are going to be alpha. And what's alpha? Alpha is the carbon atom that is the closest to the carboxylic acid, and we will name like let's add one more carbon atom and related hydrogens, and suddenly we have alanine, not aladine but alanine, but you can call this aladine if that makes it easier for the genie to light your path with amino acids. So that's pretty much it. We have alanine as like it would be glycine if it. I don't want to overwhelm you with all this information, but amino acids really have been my saving belt several times. So if you want to bet on something, then yeah, saccharides, sugars, that is, like, they can help, but amino acids, they will help you the most, probably. At least that's my personal luck experience. And but there's a reason that I had to repeat the summer, and it came down to luck. But also, I want to perhaps rethink what actually is important. But so let's take something else. Let's take a step further. And so I want to, again, like, I like to draw in the carbon atoms first, so I know, okay, what am I thinking in exactly, and then fill in the blanks. And okay, I really haven't done this in a long while. I haven't really done chemistry in 6 years now. I've been working in other fields, but looking forward to being back also to music and such. And let's add this. What is this? Remember sulfur, my trusty sulfur from my trusty Mutalisk. Well, this Mutalisk is now hanging and is a very, very vulnerable group. This is going to be the most vulnerable group of most proteins, and that's also the thing. So like, your body will not store amino acids like randomly, but inside proteins. And yeah, if you don't consume enough amino acids, then it or needs energy from other sources, then it's going to start taking it from proteins. But that's a story for another day. But so why am I so interested in these SH groups, in these thiol groups? This is thiol. All because from alcohol, like if it had OH, like a hydroxyl group would be OL because of the alcohol. And if it's like two OH groups, then it would be a diol for di-alcohol. And because like sulfur stuff usually start with something related to T, so it's the T version of the alcohol. So with S instead of O, you have thiol. So basically, you could say that what we have here is nothing else but alpha amino beta thiol propionic acid. You can call it propionic or propanoic, both names work. Usually people will say propionic acid, because you have 3 carbon atoms, and propane is propan, the alkane. Actually, I don't know how propene, like the alkane and the alkene, are pronounced in English correctly relative to the alkane. But anyway, so with 3 carbon atoms, long story short, you have propanoic or propionic acid. The acid name comes at the very end. So and between these two, there's an order as well in which order they are said. And you know what, like I think some of these orders are maybe unnecessary, but that's my own personal opinion. But yeah, if we want to keep it like that, then I think it's not that important right now. It's alpha amino beta thiol propionic acid. And if you wanted to say differently, just learn about adenine, not adenine. Again, mnemonics are great though. Like we want to add our trusty Mutalisk onto alanine, so let's make it beta thiol alanine. And why is this important? Why did I say Mutalisk? Because if you take, like, let's say O2, like let's say an oxidizing agent, actually let's take it as like molecular oxygen, and let's take 3 of them, because spoiler, because I already know what will happen, but if I didn't know, I would have to retroactively fill this out. And so we have again our 3 carbon atoms, carboxylic group, and CH. I could write in the H at the very end, and I should, because otherwise I make mistakes and I have to correct them, and then it will look less readable. And but yeah, here it's still not as critical yet. And just said that you can have sulfonic acids, and this is a sulfonic acid with SO3H. Like if you were to write this up, you would get something like this. Like in space it would be a bit differently, the angles and such, you know. But yeah, long story short, we added these 3 oxygen atoms into this, and this is no longer cysteine. And like cysteine was cis, like not I but Y, you know, this is theine, and this is cysteic acid. And why am I telling you this? Well, protein with cysteic acids instead of cysteine, I mean, this is not a pure amino acid. This is a sulfonic acid version of an amino acid. And you know what, that's it's not good. Why? Because it won't just be affecting you know, whatever you're using on